Hello students, in the last video we have seen Pearson's product moment method. I have shown you the sum whereby changing the origin and scale of the original data we have reduced the values so that our calculation becomes easy. Today again I am going to show you one more sum where the values are big, but by changing their origin and scale, we can reduce the calculation which becomes more easy. Find the correlation coefficient between the density of population and death rate for 6 cities of Gujarat state. The data is given: density per square kilometer, variable x, death rate per 1000, variable y. Now see variable x: 200, 500, 400, 700, 600, 300. You can see all these values are multiple of 100. So when we change the scale, we can divide this value by 100. Variable y: 10, 12, 10, 15, 9, 12. These values are small, so we need not change the scale. Let us do the total of x, which comes to 2700. Total of y: 68. So we calculate our mean x bar. Total divided by numbers. 2700 divided by 6. It comes to 450. Y bar: 68 divided by 6. 11.33. So one mean is integer, another mean is fraction. So we go for our shortcut method, taking variable x, changing it to variable u. X minus a, that is assumed mean, divided by 100. Variable y, we convert it to v, taking y minus b, that is our assumed mean, divided by common value. For x, as multiple is 100, we can divide all the values with 100. And for y, we are taking that as 1. So my new variable u, x minus 500 divided by 100. So 200 minus 500. So minus 300 divided by 100, minus 3. 500 minus 500, 0. 400 minus 500, it comes to minus 100, divide by 100, minus 1. 700 minus 500, 200, divide by 100, 2. 600 minus 500, 100, divide by 100, 1. 300 minus 500 divided by 100, minus 2. Now when we do the sum of these, we get minus 3. Same way variable y, we change only origin, taking assumed mean as 12. So v equals to y minus 12. 10 minus 12, minus 2, 12 minus 12, 0, 10 minus 12, minus 2, 15 minus 12, 3, 9 minus 12, minus 3, and 12 minus 12, 0. Sum of v, it comes to minus 4. Now we go for square of u, square of v, and product of uv. Minus 3 square, 9, 0, minus 1 square 1, 2 square 4, 1 square 1 and minus 2 square 4. Sum of that 19. Now v square minus 2 square 4, 0, 0, minus 2 square 4, 3 square 9, minus 3 square 9 and 0, 0. Sum of v square comes to 26. Now product of u and v. Minus 3 into minus 2, 6. 0 into 0, 0. Minus 1 into minus 2, 2. 2 into 3, 6. 1 into minus 3, minus 3. Minus 2 into 0, 0. And sum of these comes to 11. This is how first of all we prepare the whole table. Now we proceed further with the formula R equals to N into sigma UV minus sigma U into sigma V divided by root N sigma U square minus sigma U whole square multiplied by root N sigma V square minus sigma V whole square. Let us substitute this value. N number of observation 6, sigma UV 11 from the column we get it, sigma U minus 3, sigma V minus 4 divided by root N6 sigma U square 19 minus sigma V is minus 3 whole square into root 6 into sigma V square 26 minus sigma V that is minus 4 square. We simplify this value 6 into 11 66 minus 3 into minus 4 12 minus sign outside that so minus 12 6 into 19 114 minus 3 square 9 multiplied by root 6 into 26 156 minus 4 square 16 66 minus 12 54 114 minus 9 root 105 156 minus 16 that is root 140 54 divided by 105 multiplied by 140 root 14,700. Now with the help of calculator we find out the root 54 divided by 121.24. So correlation coefficient comes to 0.45. This was shortcut method where we have changed the origin and scale of the original data so that our calculation becomes easy. So we have seen three methods of Pearson: direct method, shortcut method and deviations taken from actual mean. These three methods are used for long sum which can be asked for 5 marks. Now same formulas they can be asked as short sums for 2 and 3 marks. Let us see one sum where all the values are given. You have to simply recall the formula, substitute the values and continue. N20 covariance x and y minus 50, standard deviation of x 15, standard deviation of y 8, and we have to calculate correlation coefficient. Now when covariance is given, we use the formula for covariance. R equals to covariance x and y divided by standard deviation of x into standard deviation of y. Covariance xy given to you minus 50. Standard deviation of x 15 multiplied by standard deviation of y 8. Minus 50 divided by 15 into 8 120, which comes to negative 0.416. As per our rule, the third digit 5 or greater than 5, we add 1 to the previous digit. So approximately our answer negative 0.42. Let us take one more sum, short sum only. N 10 sigma x minus x bar into y minus y bar 60. Variance of x 25. Variance of y 36. Now first variance is given, we want standard deviation. So variance of x 25. Therefore standard deviation of x root 25, that is 5. Variance of y 36. Therefore standard deviation of y root 36 equals to 6. Now we write the formula R equals to sigma x minus x bar into y minus y bar. This is the product of deviations for x taken from x bar and y taken from y bar, divided by n multiplied by standard deviation of x into standard deviation of y. Substitute the value. Sigma x minus x bar into y minus y bar 60. N 10. Standard deviation of x which we have calculated 5 and standard deviation of y 6. 60 divided by 10 into 5 into 6, 300. And 60 divided by 300, correlation coefficient R comes to 0.2. So such type of short sums for 2 or 3 marks for Pearson's method can also be asked. One more short sum, n 10 sigma xy 1500, mean of x 12, mean of y 15, standard deviation of x 9, standard deviation of y 5. Find correlation coefficient. Now remember, again and again I say that based on the values given, suitable formula is to be selected. Now as here n sigma xy, x bar, y bar, standard deviation of x and y are given, we are going to use formula R equals to sigma xy minus n into x bar into y bar divided by n into standard deviation of x into standard deviation of y. Now substitute all the values. 1500 minus 10 into 12 into 15 divided by 10 into 9 into 5. Simplify it. So minus 300 divided by 450 comes to minus 0.667. Therefore, R equals to minus 0.67. We have come across most of all the formulas of Pearson's method. Now let us see the objectives which are based on the properties of correlation coefficient. Earlier we have discussed the properties, but once again we are going to revise it. Properties of correlation coefficient. The very first one, value of R lies in the interval -1 to 1. Second, correlation coefficient is free from the unit of measurement. So, whatever may be the value units of variables, R does not have any unit of measurement. Third, Rxy equals to Ryx. The fourth point, correlation coefficient does not change with the change of origin and scale. So whether you add, you deduct, you multiply or you divide, R is not affected. And the last property, R minus x and y equals to minus Rxy, or Rx minus y equals to minus Rxy. That is, if sign of any one of the two variables x and y is changed, the sign of correlation coefficient also changes. Second point, if sign of both the variables x and y are changed, then sign of correlation coefficient remains unchanged. Now today we are going to see some short objectives which are based on these properties. First, if R minus xy is equal to minus 0.5, then what is the value of Rx minus y? It remains same, R equals to minus 0.5 as per one of the property. Sign of one variable y is negative, so R remains same, minus 0.5. Second, if Rxy is equal to 0.7, then what is the value of Rx plus 0.2, y plus 0.2? R is independent of change in origin and scale. So even though 0.2 is added to x and y, R is not affected. It does not change. It remains same. So answer, R equals to 0.7. Third, if R between two variables x and y is 0.5, then what is the value of R minus x and minus y? As per the properties of correlation coefficient, when sign of both variables x and y are changed, R remains unchanged. Therefore, R is equal to 0.5. Fourth one, if Rxy is 0.8, then find Ruv for u is equal to x minus 5 divided by 3 and v is equal to 2y plus 7. Again, as per the property, R is independent of change in origin and scale. So, R x minus 5 divided by 3, y that is 2y plus 7 is equal to Ruv will be same 0.8. Now see here, on the basis of these properties, MCQ or short objective sums can be asked. The point which you have to remember for Pearson's method is the best method to find correlation coefficient. it is based on the assumption that there is a linear correlation between two variables and there is some direct, indirect cause and effect relationship between two variables. Let us now see the merits and limitations of Pearson's method. Merits of Pearson's method. First, nature as well as the degree of relationship between two variables can be known. Either we can say there is a positive or negative correlation, and up to what extent, as the value lies between -1 and +1. Second, this is the most popular method. And third, it summarizes the degree high, moderate, low of correlation in a single number. When the value is nearer to 1 or -1, it would be high correlation, and if it is near to 0, there would be low correlation, and above 0.5 but not so near to 1, there would be a moderate correlation. Limitations of Pearson's method. First, it depends on assumption that both variables have linear relationship. So, if variables do not have linear relationship and it is used, then interpretation based on it will be misleading. Second, value of correlation coefficient is highly affected by extreme, that is too large or too small observations. And the last one, utmost care is required to interpret these coefficients. So as such, three methods: scatter diagram, Pearson's method and Spearman's method. The first which we have completed is Pearson's method. Next video I will go for scatter diagram method, where it is to be plotted on the graph paper.